Dear ladies and gentlemen, welcome to this technical track. Today I would like to give some insights into Germany's mobility data marketplace, MDM. In 2010, Materna received the order to implement and operate the MDM. Project owner is the BUST, Germany's Federal Highway Research Institute, on behalf of the Federal Ministry of Transport and Digital Infrastructure. We started in 2010 with the development, and after implementing and testing the new platform, the pilot phase started in summer 2011 and ended successfully at the end of last year. Now, the platform is a candidate to become Germany's single point of access. So it's time to look back and share our experiences with you. First, let's have a quick view on my agenda. Because not everybody knows Materna, I will give some short information about us. After that, I will go into the technique and explain the architecture. The questions who are the users and what kind of content you can find on the platform will be answered. I will present 3 special requirements and the found solutions for them. We will have a quick view on the figures of usage, and I will conclude with some experiences and recommendations for building a single point of access. So let's start with introducing the company I'm working for. Materna is one of the leading owner-managed IT service providers in the information and communication technology sector in Germany. We have around 1,400 dedicated staff throughout Europe, and we are on the market for more than 30 years. The headquarters is located in Dortmund, probably well known in Europe by our football club Borussia Dortmund. We have subsidiaries all over in Germany and also in many European countries. Let's have a look what we do. For our customers, we deliver services and infrastructure. That is what we do for the BUST with the MDM. And for that, we are operating an own data center in conformance with legal German data protection guidelines. We analyze and implement the business or administration processes of our customers and create the necessary applications for them. Here we talk, for example, about e-government or e-commerce solutions or integrated passenger services. We support them to communicate easier and better with their own customers. For example, we support them in the area of social media or by developing mobile apps. And we help them to deal with their digital content, for example, by setting up document management solutions, portals, websites, and so on. On this slide, you can see our sectors where we have expert business knowledge with a short list of our customers. For the transport sector, we also offer systems and services for airports and airlines, for example, for Lufthansa. So let's go now into the MDM. First, I want to explain the architectural concept. The MDM implements the concept of a message broker. That means the platform acts as a one-to-many data switch between the data publishing and subscribing systems. It has exactly one message buffer per publication and stores in it only one package. Every time a new package is delivered by the publisher, the package in the buffer will be replaced for push subscriptions immediately delivered to the subscriber systems. For that, the platform guarantees a dispatching time of 10 seconds for 99% of the deliveries. Full subscribers can fetch the content as they need it and will get, of course, only always the last valid package. One benefit for subscribers using the MDM is that they can use a transport protocol different from the publisher's system. So we can say, by decoupling the systems, the MDM offers a protocol conversion feature. What is the difference to a data warehouse platform? The data warehouse collects every package in its database and stores it permanently. It gets the ownership about the content. It also enables you to get access to historical data. But the consequence is that you have to pay the higher price to set up and manage a large database capacity. Therefore, it was already a given design decision of our client BUST to implement the platform as a message broker. This picture now shows the high-level architecture of the MDM. The heart of the solution is the broker kernel, for which we use the Materna product called Max, which already offers a ready-to-use publisher-subscriber implementation, approved in many projects for mobile network operators in different European countries. Around the kernel, we grouped interface components for the different data formats and protocols, inclusive the requested security functionality. We have a metadata repository and an event database for logging and billing data, and, of course, portals for the different user types. As technology, we use the Java Enterprise Edition framework. Here you see the physical structure of the MDM. It is a typical high availability Java application infrastructure with proxy web servers, a JBoss application server cluster, and 2 different databases. For the metadata repository, we use an Oracle Real Application cluster, and due to some special requirements, the event log for all the transactional data is set up by an Apache Solaire database. To get the requested redundancy and high availability, the deployment is split over 2 sites on different locations. That should be enough. Let us see now what kind of users and contents we have. The users are coming from regional authorities, municipalities, from the industry, especially automobile manufacturers, automobile associations, and private service providers. And last but not least, an unexpected big new user group arrived last summer on the platform. It is a market transparency unit for fuel, a branch of the Bundeskartellamt, that is Germany's competition authority, followed by a lot of mineral oil companies and petrol station operators. That's coming from the German government's decision that each petrol station must report the change of fuel prices to the transparency unit in real time. Because everything must go very fast, the MTSK decided to use the approved MDM instead of implementing an own infrastructure. Which content is offered today? We find traffic messages like alerts, traffic jams and so on, roadworks, traffic management measures like alternative route recommendations, parking data, traffic measure data from loop detectors, and weather information. And the next content type was not really expected. You can get their motorway webcam pictures, which are delivered in the MDM container format, which I will explain soon. And of course, with the biggest throughput of all, the fuel price publications, where special Datex II Level C extensions will be used to make the handling more efficient. Here we have one static publication with station information and one dynamic with the actual prices, which will be delivered high frequently from many organizations. So here we come directly to one of the 3 requirements I will present in detail, the container format. There was already from the beginning the requirement to offer an interface to exchange any data, independent from the data format. The MDM container format was already defined by the bus for that use case. It is an XML formatted transport format with 2 content parts, one header and one body part. And this body part could hold any required data. That could be, once again, XML content or binary content like images. And that is really important. It could also hold collections of data objects, like a zip archive, which was helpful for the next issue. This we named the many-to-many issue. It was discovered after these many fuel price publications arrived on the scene. There are more than 700 publications and more than 200 organizations were interested in receiving this data. The bandwidth of the platform was not sufficient to handle so many web requests, and there was no budget to order more hardware to solve the problem. Therefore, the MDM container collector feature has been added to the platform. What's that? An additional MDM component bundles all data packages of the same data type in one container package and offers this package as a new publication. Now the subscribers must only receive one package for fuel prices and one for station information to get all the information. Maybe this feature could be reused in the future for parking data, because the parking space facilities are also controlled by many different organizations. The last requirement to discuss was formulated by some public authorities for security-relevant real-time traffic information. They wanted to monitor the delivery of the content to the subscriber systems, because the MDM gives the positive acknowledge only for handing over the data package to the broker and not for shipping to the subscribers. Another solution must be found. We developed the end-to-end delivery control feature. For that, the broker measures the delivery time for dedicated publications. If the delivery fails or is delayed, the MDM sends an email notification to the publisher, enabling him to ship the critical information on a different way. Also, the subscriber can get an email for that case if he wants. Let's have a quick view on the figures of usage. Today, we have round about 2 million systems transactions per day on the platform. Over 700 organizations are registered with 1,200 publications and round about 16,000 subscriptions. For comparison, the system infrastructure was originally configured for a pilot phase with only 40 organizations and 1,600 subscriptions. That to give you an impression of the scalability of the system. And here we have a slide that shows the dramatically increasing figures after starting the use case to collect and distribute the fuel price information since mid last year. Please notice the logarithmical division at the y-axis. So let's come to the finally. I would like to give some recommendations for implementing a single point of access based on our experiences. At first, from my point of view, it's a fact. Datex II definitions are not available for all use cases, and sometimes it makes no sense to manage all information by such a definition. So you should think about a suitable transport format like the MDM container format. Next, if the content generation is heavily distributed as we found in our fuel price scenario, this could be an issue if many parties are interested in receiving this content. So think about content collection, or even better, content aggregation functionality for your SPA. And last, your SPA will probably deal with many external systems. Monitor these systems and measure the response times. At the MDM, we realized that slow subscriber systems have blocked system resources and slowed down the system performance. So it is a good idea to have some monitoring functionality and something like an emergency switch to stop the delivery to some poor, slow systems. So let me conclude. The MDM is running roundabout for 3 years, stable and with really good performance. And we can say the chosen architecture has passed the pilot phase successfully. We found that the architecture is sufficient scalable for a big number of players. The decision to use the J2EE technology to build the system was the right decision. The broker concept is well qualified to set up a SPA with reasonably costs. And finally, the MDM is ready to become Germany's single point of access. If you have any questions, maybe at the end of this session. Otherwise, feel free to ask me anytime here during the conference or later on by email. Thank you for your attention.